Hi everybody from Switzerland again. Here I am with spirals. Since I received many emails asking me to show how to build a spiral, I will do just that. Blue one that makes 1, 2, 3, 4, 5, 6, 7 windings, and it ends right there. It's not connected to the red one, of course. And this is the red one that makes 1, 2, 3, 4, 5, 6, 7 spirals and ends right there. You see, it's not connected. See, it winds out. And here you have the two coils. And this is why you actually have to be very precise when you prepare the spiral and when you drill the holes, so that you will have an easy setup when you do this. See? Here it is. This is my way to do it in order to have the positive and the negative attachment only on the top. So you can put it into a container. You don't have to drill holes on the bottom. This you should be able to do afterwards, so you have to leave enough material when you wind it that you can do this. So you prepare this one before you start the coil. When you do not have the same distance, you take the coil and you pull it or push it. If you want to open from here to here, you hold it before and after, and then you pull like this, or you push, just gentle. One winding for the double spiral, so you will have the exact same diameter. The measurement you take here is the same measurement you will have on your plastic or acrylic that you will use. See, you make the holes and you make the extra holes for the next winding. Don't make the holes too tight, otherwise you cannot wind it. It is too hard. You need the rings to go on top, and there has to be enough distance here for the thread to be in between. On a support, I will weld it, and I will weld it just about 1/16 of an inch out, so that when the handle turns around, it's not going to hit here. You see, it's a little bit too big. Then you take the same tube, you cut it like this, you make this cut, and then you just squeeze it. And I would like to remind you that this way to build a spiral is my way to do it. It is not by any means the way the industry does it. But I think it helps to know how to make it in a cheap way on your own. And make some exercise if you've never done it before, so you don't waste precious stainless steel. And there you go. And you have a very tight. And what's important, that you have enough room in between so you can go through with the wire, as you can see. Now I've drilled a hole here. This is about a little more than 1/8 of an inch. To cut it open towards the end, I suggest you use a little machine like this, and then you use a grinding blade. You see, this is a very thin. This is 1/24 of an inch. It's extremely good to cut because it doesn't overheat. Whenever you work with stainless steel and you have to drill holes in it, remember you need to cut in half the speed of drilling velocity that you have while you drill steel. and this is what you get. In order to do this kind of shape, to get it, I'll show you how to make it. You take it this way, it is like this, 2 times 90 degrees. The reason for all this is this one. You go, you put your in here, and you have the possibility to turn around. You can bend your wire towards the right and up, or towards the left and up. Depending on how you bend it, it decides on which side the coil will be turned, left or right. That allows me to turn right ways, and I can turn like this. You take it out like this. This spiral needs to be opened. You see, it has to go like this, and this is a hard work to do on 1/8 of an inch stainless steel, I guarantee you that. See, and there you have your spiral then. You have the wire that is inside. This is the other piece of the wire. I suggest you take a glove or a piece of cloth, and then you start, and here we go. Steady speed. Here you go. Here is the coil, like this, and you take it out. And when you turn it around, every time it gives a hick, and that's what you heard when I was turning. It must tick, tick, tick every time it turns here. So bend it a little more, so you have it round, like this one here. 1/12 of an inch thickness. You see, it's all bent up, you know? And it goes back. Then you take it in the middle a little more, and you take it on the side a little more, take it here a little more, until you have the size you want. When the diameter is not the same, you see that there is a difference in height, then you go and you just twist it back like this. You hold it, and then it opens or closes again. The thin thread is not easy to close, it's easier to open. Here's too little, you open it again, and you have it. Then there needs to be a space here, otherwise it will not pass, you see? Cannot be longer than this. And positive and the negative, and then I stick it into the water. I have a lot of electrolyte in here, and the electrolyte, the quantity of electrolyte you put in here, or Coke or soda or whatever you want to use, baking soda, will decide how much amperage is going to draw. Negative, and look what happens. This is how simple it is. I'll take it away. I'll put it to the battery, and here we go. This is production of 1/8 of an inch thread. Once again, this is how easy you can produce hydrogen. The task is not how to produce it, the task is how efficiently we want to produce it. And here is where I ask all the electronics guys to talk very simple when they explain it and teach us how to do it. I have in laser cutting, I have plates being cut, and I'll bring a supercell in about a week or two, maybe guess more 2 weeks about time, and you will see a nice piece of work. The next time you will watch. Goodbye to everybody.